Hey guys, welcome to lesson 3 in unit 2. We're going to keep talking about solving equations in this lesson. So let's take a look at our aim. It says I can solve equations where the variable appears on both sides using inverse operations. So far we've only been dealing with equations where the variable appears once on one side. This lesson is going to talk about what happens when the variable appears on both sides. So let's read. The expectation of the Common Core is that students have mastered solving all types of linear equations in 8th grade. Common Core Mathematics. In this lesson, we simply present a variety of linear equations for you to practice solving. Exercise 1. Solve each of the following two-step linear equations. Keep in mind this is what we were doing in the last lesson by reversing the operations that had occurred to the variable. Some of these answers will be non-integer rational numbers, which means it could be a fraction. So sometimes you might get a fraction, and that's okay. Simplify where possible. Okay? So, if you want, there are 9 problems in the very beginning of this lesson. If I were you, I would pause the video now and do these 9 problems on your own, and then come back and check and see the solutions. Okay? Because a lot of you I know can do these on your own. You don't need me to walk you through it. I'm going to go ahead and start solving them, and you can watch, or you can pause and try them on your own and come back and check later. Okay? Letter A. I'm going to add 7 to both sides. The 7's cancel out. I'm left with x over 3 equals negative 2 plus 7 is a positive 5. I need to undo this division, so I'm going to multiply both sides by the denominator 3. The 3's cancel out, and I get x equals 15. Final answer. Problem B. The first step, subtract 3 on both sides. I'm left with 4x equals negative 17 plus negative 3. If you want to put a little plus sign right there, this is negative 20. Use your calculator if you want to for your negative numbers. Then divide both sides by 4, and x equals negative 5. Letter C. First step, subtract 12 on both sides. The 12's cancel out, and I'm left with 5x equals 87 minus 12 is 75. Divide both sides by 5 to get x by itself, and x is going to equal 15. Final answer. Letter D. Here we start off with a division problem. So the first thing to do is undo that division. So we're going to multiply both sides by 3 to cancel out that denominator. So I'm left with x plus 7 on top equals 2 times 3, which is 6. Last step, subtract both sides by 7, and x equals negative 1. Letter E. I could distribute first, or I could divide first. So let's distribute first. Do negative 6x. Negative 6 times negative 1 is a positive 6 equals 18. Now I can subtract 6 on both sides and get negative 6x equals 18 minus 6 is 12. Divide both sides by negative 6, and x equals a negative 2. I could have also done this. This can be done, there are 2 ways to solve this. I could have also divided both sides by negative 6 first. That would have given me the same answer as well. Letter F, first step, subtract the 2. The 2's cancel out. 8x equals, again I'm going to put a little plus sign here. Negative 2 plus negative 2 is a negative 4. Divide both sides by 8, and I get x equals negative, x equals negative, sometimes my pen does this and it's frustrating, negative 4 over 8. If you put that in your calculator, negative 4 divided by 8, you get negative 1/2. So be careful with your fractions and use your calculator to help you. Finally, the last 3. I'm going to extend the page a little here. Give me some more room. Letter G, first step, add 5 to both sides. These cancel out. I get 3/4 x equals 4 plus 5 is 9. Now, what I'm going to do is this 3/4 x, I'm going to rewrite it as 3x over 4, and then I'm going to multiply both sides by that denominator to cancel it out. Then 3x is going to equal, let me rewrite that a little bit, 36, divide both sides by 3, and x is going to equal 12. It's okay to rewrite a fraction. So that 3/4 x, I just rewrote it so the 3 and the x were on top. Anytime you have a fraction next to a variable, the variable can go with the numerator, right? Alright, letter H. First step, subtract the 6. The 6's cancel out, and I get negative 5 over 2x equals 1 minus 6 is negative 5. You can also always put that plus sign there and do 1 plus negative 6. Same thing here. I'm going to rewrite this as negative 5x over 2 equals negative 5, and then get rid of that denominator by multiplying by 2. So I get negative 5x equals a negative 10. Negative 5 times 2 is negative 10. And then finally divide both sides by negative 5, and I get x equals a positive 2. Okay? And finally, letter I. Subtract 3 from both sides, and I get 6x equals, put a plus sign here, negative 1 plus negative 3 is a negative 4. Divide both sides by 6, and x equals negative 4. I don't know why my pen does this. Negative 4 over 6. Now put this in your calculator, or if you can reduce it in your head, reduce it in your head. I know that in my head this reduces to negative 2 over 3. Fractions are okay to get as a final answer. So this should have all been reviewed. Check your answers, make sure you feel good about this, and let's take a look at the next section. So now we're going to talk about what happens when we have more complicated equations. So for most of what we do the rest of the way, you'll be using the distributive property as well as others to solve problems. Don't forget our primary technique of solving by reversing the operations that have been done to the variable. This technique is particularly useful when the variable shows up only once. So notice that in exercise 2, that x only appears once. So this appears once. So exercise 2 says solve the following equation for x by identifying the operations that have been done to x and reversing them. So let's list the operation. The first operation that's done, let's look in the parentheses, is we subtracted 3. The second operation was we took that and then multiplied it by 5. After that, let's take a look at the division. We divided it by 8. Then we finally, as the fourth step, we added 2. Okay? So the reverse would be, let's write that out. The reverse would be step 1. So we look at step 4, and that says added 2. So reverse would be to subtract 2. The second step, divide by 8. Okay, so we're going to multiply by 8. Third step, multiply by 5. So we divide by 5. And finally, we get back to where we started, where we subtract the 3. So we're going to add the 3. And then let's take a look at what that looks like when we actually do the math. So 5 times x minus 3 over 8 minus 2, plus 2, equals 7. So the first step was to subtract 2. I'm going to subtract 2 from both sides. 5 times x minus 3 over 8 equals 7 minus 2 is 5. So check step 1. Step 2, multiply by 8. Times 8 on both sides. The 8's cancel out. 5 times x minus 3 equals, well, 5 times 8 is 40. So that was step 2. Step 3 now says divide by 5. And I am left with x minus 3 equals 40 divided by 5 is 8. So that was step 3. And the last step is to add 3. So x equals 11. Okay? So just a little bit more complicated, but we can still do problems like this with one variable by inverse operations. Okay? So what happens when we have problems where there are two variables? So let's take a look. Let's read this. It says, okay, now move on to problems where this technique is used, but only towards the end. We also need to review how to solve problems where the variable shows up more than once. Key here, the variable shows up more than once. Since this is a review, we're going to jump into a very complex scenario. So notice that the variable is showing up here, and it's showing up there. So it's showing up in two different places in the equation, versus if we go back, this only showed up one time in exercise 2. Right here, it only showed up once. Same thing for all of these problems. It only showed up one time. I'm underlining them here, 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 only one time. So now we're moving on to problems that appear in two places. So let's walk us through what the steps are for this. So part A, let me get my pen. Okay, part A, by using the distributive property, write equivalent expressions for both sides of the equation. So this is saying, okay, the first thing you should do here is distribute. So I'm going to rewrite the equation, 5 times x minus 3 plus 2x equals 4 times x plus 3. And I'm going to distribute. So I'm going to distribute the 5, and I'm going to distribute the 4. This becomes 5 times x minus 5 times 3, and carry down the plus 2x, and this becomes 4 times x plus 4 times 3. So simplifying it, I get 5x minus 15 plus 2x equals 4x plus 12. Okay, now that we've distributed, we need to combine some like terms. So I see that 2x and 5x are like terms on the left. There are no like terms on the right. So 5x plus 2x is 7x minus 15 equals 4x plus 12. So now I've got equivalent expressions on both sides of the equation. Okay, so now letter B says solve the equation for x. So how do I take this, I'm going to rewrite it, 7x minus 15 equals 4x plus 12. And how do I know what to do now? Because I've got x's on both sides and numbers on both sides. It's confusing. Well, a good rule of thumb is always try and get x on the left side. So this means get rid of x on the right. Okay, so always try and get x on the left side, get rid of x on the right. So the x on the right, and I don't know why my thing has this on here. Okay, so this equation, it's got a 4x on the right. I don't want this 4x here, so to get rid of it, I can subtract it. I'm going to subtract 4x. If I subtract 4x on that side, I've got to subtract it on the other side. Well, 4x minus 4x is 0. That's why it cancels out. 4 minus 4 is 0. And over here, I notice I wrote the 4x under the 7x because they are like terms. 7x and negative 4x combine to 3x. I bring the negative 15 down and bring the 12 down, and now suddenly I've got an equation I can solve with my reverse operations, now that I only have one x in my situation. So, next step, add the 15. Whoa. I don't know how that 15 got so big. Okay, these cancel out, and 3x equals, what's 12 plus 15? 27. Divide both sides by 3, and x equals 9. Now that's not all that this said. What other part of the direction did it say? It said now check. Check to make sure that your original equation has a true value for what you find. So this is my original equation. So what we're going to do to check is we're going to plug in 9 into our original equation. So here's our check. So my original equation is 5 times x minus 3 plus 2x equals 4 times x plus 3, and I'm going to plug in, instead of x, I'm going to put in a 9. Instead of an x here, I'm going to put in the 9. And I'm going to see if it comes equal on both sides. So this is 5 times 6. Oh, look what I forgot to do. That 2x. I forgot to replace that x with a 9. So this should be 2 times 9. So 2 times 9 is 18, equals 4 times 9 plus 3, which is 12. 5 times 6 is 30, carry down the 18, and 4 times 12 is 48. And finally, 30 plus 18 is 48 as well, so it looks like my answer of 9 is correct. So I'm correct. Okay? It gets tougher when there are variables on both sides. I know that. I know that it can be a struggle and you don't know what to do, especially at that step right there. But remember this, always try and get x on the left side, get rid of x on the right. You don't have to. If you wanted to subtract the 7x over first, that would have worked as well. If you wanted to subtract the numbers first, you could have. This type of problem right here, there are many different ways to make the next step. Okay? Finally, I'm going to do 2 more in this lesson. If you like, you can pause the video and try these 2 on your own and get a taste for what it feels like on your own, and then unpause and again see if you got your work correct. Now again, read the directions here. It says that check your final answer to make sure it's true. So both these equations are asking for a check. Alright, so let's start with A, and I am going to recommend you be very neat and careful with your work. Sometimes it's hard on these videos for me to be very neat because the pen isn't always very sensitive and it misclicks. But, you know, try your best to keep it really organized, okay? So, letter A, we're going to start by distributing, and I'm going to make my distributing marks for all 3 of these. There's 3 different things to distribute, so we have to be really careful. So, first distribution, 7 times x is 7x. Then, 7 times negative 2. That's a negative 14. Okay, I'm not writing the plus sign here because I don't need to. You could put plus negative 14. If I wrote plus negative 14, it's the same thing. I'm just not going to put 2 signs next to each other when I know that I can just put a negative 1. Okay? Now the next distribution. You know what? In fact, I'm going to do this in a different color because it's a lot of distribution. So I'll do this next one in red. So then I have negative 3 times x. That's a negative 3x. Again, I'm not writing a plus sign. I'm just keeping the negative. Negative 3 times a positive 3. That's a negative 9. Equals, the next distribution I'll do in blue is 5 times x minus 3, so 5 times x is 5x, and 5 times negative 3 is negative 15, and I'm just going to carry down that x right there. Oops. Nope, see, I just got done saying that my pen does weird things, well there you go. Okay, now we can combine like terms, so I'm going to combine on the left side. I've got a 7x and a negative 3x, and I've got a negative 14 and a negative 9. So 7x and negative 3x combines into 4x, and the negative 14 and the negative 9 combine into a negative 23. That's the left side. On the right side, my 2 like terms are the 5x and the... How many x's is this right here? Well, there's an invisible 1, so I can put a little 1x there and know that 5 plus 1 will give me 6x, and then just carry down the negative 15. Okay? And now I'm ready to do my get all of the x's on the left side. So I'm going to start with this 6x right here, and I'm going to get rid of it. I'm going to move it over to the left side. So these cancel out. 4x minus 6x is negative 2x. Bring down the negative 23. And then these cancel out to 0, so I'm just left with a negative 15 on the right. And now suddenly this becomes a much easier equation. The next step is to add 23 to both sides. They cancel out. I'm left with negative 2x on the left side, and negative 15 plus 23 is a positive 8. Divide both sides by negative 2, watch your signs, and x is going to equal a negative 4. And we need to do our check, right? Because remember, it's set up here, we have to check, and it's really important that we're following directions. Yes, this takes a lot of time and space. This video is running into a little bit over 20 minutes, but these equations are complicated and they're going to require a little bit more time. So let's do our check. So here's my check. My original equation is 7 times x minus 2 minus 3 times x plus 3 equals 5 times x minus 3 plus x. Wherever I see an x, what am I going to put? A negative 4. So 7 times negative 4 minus 2 minus 3 times negative 4 plus 3 equals 5 times negative 4 minus 3 plus negative 4. And now we do PEMDAS and simplify. Negative 4 minus 2 is a negative 6. Minus 3 times negative 4 plus 3 is negative 1. Equals 5 times negative 4 minus 3 is negative 7. And then I can just drop this plus and put minus 4. Okay? Now we multiply. 7 times negative 6 is negative 42. Negative 3 times negative 1 is a positive 3. And 5 times negative 7 is negative 35. And then the tack on the negative 4. Negative 42 plus 3, that is a negative 39. And look at that, negative 5 minus 4 is also a negative 39. So I know that my answer of negative 4 was correct. Okay? Alright, we're reaching the end. Stay with me, we've got one more problem left. Letter B. Let's do it in blue. Okay? Alright, first thing I do is distribute. This 9 minus 6, I want to be really careful with this. PEMDAS says you do what first? Parentheses, then exponents, then multiplication. So should you be subtracting at all as your first step? No, not when you see that there is a 6 here that needs to be distributed. So I need to distribute the negative 6. So I'm just going to drop the 9 down. Drop the 9 down and distribute the negative 6 to the x. So this becomes minus 6x. Negative 6 times 1 is negative 6. Please be careful there. Don't subtract this first. Don't do it. Always distribute first. Okay? Equals. Distribute the 2 times x and 4. So 2 times x is 2x. And 2 times negative 4 is negative 8. And bring down the 27. Now we're ready to combine like terms. I only see a 9 as a like term with negative 6. So I'm going to bring down the negative 6x, and 9 minus 6 is a positive 3. Over here, I see negative 8 and a positive 27, while negative 8 plus 27 will give me a positive 19. Now I'm going to get this x over on the other side, so I'm going to subtract it over, and get negative 6x minus 2x is negative 8x. Bring down the 3. These cancel out, I'm left with 19. Subtract the 3 over because I'm trying to get x alone. Negative 8x equals a 19 minus 3 is a 16. Divide both sides by negative 8. And x equals negative 2. Okay, and finally, and then this video will be over, we have to do our check because we have got to follow directions. Okay, if you want, you can skip ahead and see the check for yourself. You don't have to watch me work it out, but that's up to you. I'm going to rewrite 9 minus 6, x plus 1 equals 2 times x minus 4. I'm going to suggest you watch me just because it's good practice, especially if you're not taking the Regents and you want to check your work. So 9 minus 6, I'm going to plug in a negative 2 wherever I see x. So this becomes negative 2 minus 4. Alright, 9 minus 6, a negative 2 plus 1 is a negative 1. And negative 2 minus 4 is a negative 6. Gotta scroll down a little bit. This becomes, now remember, this is negative 6 times negative 1, so it's a positive 6 now, because this negative and this negative make a positive, equals 2 times negative 6 is negative 12, plus 27. 9 plus 6 is 15, and negative 12 plus 27 is also 15, so I'm good to go. Thanks for your patience this lesson. I know that solving complex equations like this can be tricky. Keep in mind the few things I mentioned that are important, that you're trying to get the x on the left side of your equation when you've got two variables, and to really pay very close attention to your signs when you're distributing. That's where you're going to make a lot of errors. So good luck. Check with me in class if you need help, and I'll see you next lesson.